Right, so this will be part 2 to cover the last page on the Chapter 9 review. So it says the square tarp you are raking leaves onto has an area of 150 feet squared. What is the side length of the tarp? So think about this. If it's a square, it's 150 feet squared for the area. Squares have the exact same length and width. So the area formula for this would be length times width is equal to that 150. And x times x for the length times width gives us x squared. So this is really just us solving a simple quadratic equation with square roots. So only the positive answer makes sense here. So each side of the tarp is about 12.15 feet, and there's a little bit of rounding involved with that. Okay, zero product property to solve each equation. Zero product property is once you have it factored, so this was already factored for us, you take both of those pieces and you set them up equal to 0 and then solve for the variable. Alright, so on this one it's a two-step where we had to subtract 2 and then divide by 3. This one we simply added 5 on each side to get its answer. Alright, so zero product property here. This is one where we still set this part up equal to 0, and I set the d equal to 0 as well, and there's nothing to solve on this one. As soon as I set it equal to 0, it's solved. The second piece, I just add 8 on to both sides. Alright, and that's kind of a warm-up to get us ready to solve by factoring. Now remember, to solve by factoring, you must equal 0 before that. So that's why on number 1 here, you see me subtracting 7x from both sides. And then we enter into the process on factoring. If you're unsure about factoring or still shaky on your factoring abilities, you really need to come see me, because we're going to need to sort that out. It's going to be on this test. It's going to be on the remaining portion of Chapter 9 a lot. Factoring is very important. This is the easy type, where I'm just looking for numbers that multiply together to give me 12, that also add together to give me a negative 7, starting off with x squared being x and x. Now on this, remember, you can always FOIL this back out to get the correct answer if you want to double check your work. And then once you have it factored, this is no different than the above problem. You set up each piece equal to 0 and solve. If you want to check that this work is correct, plug an x back into the original equation and make sure that you get the answer of 0. So I'll just show you this one quickly. I'm plugging in 3. 3 squared is 9. If I plug in a 3 here, we'd have negative 7 times 3 is minus 21. We have plus 12 here. Well, 12 plus 9 is 21. Subtract 21 gets us the answer of 0. So I know that that answer would be correct. And you could do that with the 4 as well. You can always check these answers moving forward. Alright, on this one here, this is the more difficult type of factoring, where there's a number out in front. No GCF on these, so I'm forced to deal with it. To start off with 2x and x. Then you're still looking for factors of negative 18. But now when I place those in the proper spots, it has to be so that when I FOIL this out, that this multiplied together added with this multiplied together gives us that negative 9x. So these are a little bit more complicated because it's no longer factors of this that add to that. We'll have to FOIL it out to make sure that it works there. All right, but this isn't going to be a video designed on factoring. We've covered factoring plenty in class, but if you're still struggling with it, because a lot of people are, come see me and we'll sort it out. But then once you get it factored here, you take both pieces, set them up equal to 0, and solve. So this one here is one of the newer types we saw, where we get it equal to 0. And this isn't factored from the above methods. This is just easier. You utilize the fact that there's a GCF of x in there. Both of those are divisible by x. And then you'll get the x pulled out, x minus 3 remaining when both of these lose an x. You set up both pieces equal to 0 and you solve. All right, this one here also has 2 terms, but you could think of it here as a 0x, which means I need this one to factor from the traditional standpoint. But this is one of the special cases where they're both perfect squares and it's 2 terms. So you perfect square your 16, x squared for 4x and 4x. Perfect square your 25, a 5 and 5. And the reason one's positive and one is negative is so that when I FOIL this out, I'd get a negative 20x and a positive 20x, which gets me that 0x I was looking for. Then beyond that, take both pieces, set them up equal to 0, and solve. All right, this one here, another one of the more complicated type of factoring. And you'd want to double check here that 4x times 1, which is 4x, plus 3x times 2x is 6x. 6x plus the 4x does give me that 10x, so I know I've done this one correctly. Set up both pieces equal to 0, and solve. So if you're struggling with the factoring component, come spend some time with me and we'll get it sorted out. It's hard to do on a video because it requires active problem-solving skills on your part, and so I really need to be with you in person to get you going.